Hey Techno Studs! Up until now, we've done a lot with local area networks and a little bit with routing between those local area networks. But what we haven't discussed in depth yet is about WAN technology, or wide area networks. So in this video, let's discuss WANs, or wide area networks. In this video, we're going to start out by talking about WAN connections and what WAN connections look like. Then we're going to get into ISP, or Internet Service Provider connections, and what we specifically see with Internet Service Providers. Then we will wrap this up in talking about WAN types. What are some of the WAN technologies or types that you would see out there in the workplace? So since we've talked a lot about LANs, or local area networks, let's compare and contrast what the difference is between a LAN and a WAN is. Well, a LAN is defined largely by the protocols found in the IEEE 802, and a lot of the technologies fall into there. An example of that is Ethernet. Ethernet is one of the things that's defined in that 802 range. So Ethernet is a LAN technology. And so where the LAN ends is where there is a layer 3 device that divides up your LANs. So in this example right here, we've got a layer 3 device, a router, and this would be considered a LAN right here, a local area network. Now, to a certain degree, these also in between here, between these routers, could also be considered a LAN as well, because we could be running Ethernet in this connection right here. And so these could also be considered. But really, the big ranges in between these LANs, we consider all of this the WAN technology, or the wide area network. It allows us communication between all of our LANs. So that is what a wide area network is. Let me put it in a little different context here, because this will actually explain it even better. And a WAN, a wide area network connection, generally is considered that we're connecting our different sites. So in this example right here, we've got our headquarter office in New York City. We've got a branch office in Chicago. We've got a office in Seattle, and our factory maybe down in Dallas. So these need to be connected. There could be one or many different LANs at each one of these sites. But what we want to do is we want to interconnect these sites. So somewhere on the site, we're going to have a router on those sites, and we're going to connect these sites together. And it could possibly be where it's like this, where we have a hub and spoke, or we might have some sort of mesh network, whether it's a full mesh network or a partial mesh network. But the idea behind this is our WAN right here, our wide area network, connecting our different sites together. Now, there are some nuances. There are some different terminologies, like a metropolitan area network, a MAN, or a campus area network, a CAM. There are some nuances like that, but for the most part, this is our WAN, okay? And so a WAN generally uses some different technology over our local area network. So let's talk more about those different technologies and different things we would see in association to our WAN. There is one thing to note when it comes to these wide area networks, or even to a certain degree, even our local area networks, is the difference between serial and parallel. Now, a lot of times we see parallel when it comes to really localized traffic. And really, some of our equipment has parallel communications. An example of that would be a motherboard. I've got a circuit board right here, and it has multiple lines of communication on it. There are some cables, especially older cables, that were set up to be parallel. So it would communicate multiple bits at a single time. Could communicate across 8 lines. It could create a whole byte at the same time. Or into our CPU, we have lots of lines into our CPU on our motherboards that it's communicating multiple lines into it. So that's parallel. Now the problem is as we extend out the distance that our data communicates, these parallel lines become very difficult to do. So if you imagine a cable that just has a few conductors in it versus a cable that has many conductors in it, that can be problematic from an expense perspective, but it also can be problematic from crosstalk, where the lines end up bleeding into each other. So really, when we're talking about this communication on both LANs and WANs, we generally see that it is all set up with serial communication, where it is one bit at a time. Maybe you have just a few conductors that are carrying the signal across from point A to point B, and it's only sending a bit of information at any given time. So that's the difference between serial and parallel, and serial becomes much more prevalent the further we go out. In fact, we really don't see even our computers now connect in these short little distances using USB, which is Universal Serial Bus. They're using serial cables, and that's because of that expense and those other issues that come up with parallel. In our network fundamentals, we also talked about network topologies, and we talked about the difference between our physical topologies and our logical topologies. And we talked about topologies in relationship to our different layers, layer 2 and layer 3, and how the communication is set up. Well, this is no different when it comes to WAN technologies. We have some that are bus technologies. We have some that are star topologies. We have some that are ring topologies. We have some that are mesh topologies. So we've got different network topologies when it comes to our WAN connections as well. There are 3 different types of WAN connections: dedicated, switched, and internet. Switched actually has 2 subcategories to it. One of them is circuit switched. So you got circuit, and then you also have packet switched. So let me explain the difference between these different types. First of all, dedicated. Dedicated means that you have a line that only your data communicates across it. So an example here is maybe I have a headquarters here in New York. Maybe there's a satellite campus in Chicago. I have a dark fiber that's stretched between the two. Now this is a dedicated line between them. Or maybe I have multiple buildings here within New York, and there is a wireless connection between these 2 buildings that's dedicated, that no one else is using that line between those 2 buildings. So that's dedicated, where you have a line, whether it's copper, wireless, or fiber, that's dedicated to you and only you are using it. Then you have switched. The key purpose to this is it is shared. You're sharing the line with others. And the circuit switch would mean that you have the line for a certain period of time. Maybe it sets up the call and then you can communicate across it and then it comes back down. So that's, you're sharing it for a certain period of time, or there's other technologies where it's shared. Or it's packet switched, which means you just send a packet and it goes across that line and then it gets sorted out on the other side. So that's packet switched. And we'll talk more in depth into those 2 and the differences between those 2. Then we have the internet. The internet, the idea behind the internet is that there is this big cloud and you are connecting your devices through internet service providers up to this cloud. And then you make connections between your devices through the internet. And so this requires a little bit of setup with security. You need to make sure that you're secure across this, so you set up something like a VPN. Although the other instances with switched and dedicated, you probably want a VPN too, just for safety purposes. But these are the 3 different types: dedicated, switched, and internet. So let's go a little more into dedicated and what dedicated is. As I mentioned, it means that you have control over that line, that no one else is using that line. You have a dedicated line. An example of this, one of the examples is like a T1 or E1, a T3, E3. So those are something that you would then subscribe to through an internet service provider or through some sort of provider, and then they would make a connection between two of your sites and you would pay for that. Another example would be a dark fiber. So the meaning behind a dark fiber is that these internet service providers run these long lines between these long distances. And when they run these lines, they're not just running a single fiber, they're running lots of fiber. And they're using it as the backbone for their network. But there's some of those fibers that aren't used yet. And it's called dark fiber because there's no lights that are going down there. There's no communication that's going down it. And so then what you can do is you can lease that dark fiber, and now you have ownership, or you're leasing that dark fiber across those lines. So you can connect these two buildings, these two sites, using dark fiber. Now, one of the disadvantages to this is it's very expensive because you are using up quite a bit of potential bandwidth there with that line. And so the cost of this can be quite a bit. But the pro of it is that you have full control over the data that's going across there. So it could be more secure. It could be that you have more control over what type of communications and how the communication happens across that line. And then there's a lot more flexibility with it, and the quality is good. It can create more simplicity with the way you manage it. So there's a lot of advantages, but the big disadvantage to it is that it comes at a very steep cost. One of the types of WAN connections that we have is a circuit switched type. Now this one isn't as readily used because of the disadvantages it has, but it's still out there. And the reason why we still occasionally run into this is because there are buildings out there that are old buildings. There's infrastructure out there that's old infrastructure. And what do they have in this old infrastructure? What kind of cables do we have running to this old infrastructure? We have power, we have old phone lines that are running to these. So although we consistently are converting things over to fiber and faster connections, we still, in some of these old buildings, have these older connections. So we still utilize, to a certain degree, the plain old telephone system, these older copper connections to these buildings using circuit switch technology. Really where we see this circuit switch technology being used is the last mile. What I mean by that is in these cities, you have central offices that have old phone systems that are connected to your buildings. And this is what the last mile is. And it's the most expensive part of trying to set up this infrastructure. And really what we do is we still maintain the regular backbone services that we have with this. But this last mile is sometimes the more difficult connections that we can establish. So we use circuit switch technologies to create connections in this last mile here. And the con of this is it's just really slow. These connections are really slow. It's using like the public switch telephone network, the PSTN, or plain old telephone system, the POTS lines, to communicate across it, and they're just not designed for data or any fast data, and so they can be really slow. ISDN is another example of this, of communications that can be set up as a switched network. So the advantages is that there's a lot of buildings out there that still only have these type of connections, so we still can get at least something to those buildings, so that way we can get connectivity. Then we have packet switched. Packet switched is all the technologies that we've been talking about. We've been talking about taking data and breaking up into little packets and then sending it across these lines. So that is packet switched. We would use packet switch connections probably in almost all cases nowadays. So what I mean by that is if we were to get a dedicated line, we would probably still use packet switch technology to get our information from one of our sites to another site. And the reason why we would do that is because we could have multiple streams of communication going on at any given time. Now, so what do I mean? Why am I calling out this separately? And the reason is because when we are paying for our connections between our different sites, we may be paying for a packet switched shared network. What that would look like is you would have service providers that would be placed all around the world or all around, your area. And then you would make connection to these different service providers, and then they would have a network of interconnected buildings, interconnected networks all throughout here. And you are sharing these connection lines with other people, with other businesses. They're shared lines, but they're just shared via packet switched networks. So that is another way we could go, is we're buying some bandwidth on these shared connections between all of our different sites here. Now, this can come at a bit of an expense, especially to things like internet and plain old telephone systems, but we get some guarantees when we get this type of connection. Some legacy examples of this would be things like frame relay and ATM, which really are not used as much anymore, but some more recent examples that are still commonly used, are things like Metro Ethernet and MPLS. So that is packet switched and how we can share lines of communication with other companies and other traffic using this packet switch technology going through a service provider. Then we have the internet, whereas when we have dedicated and it's just us that can use those lines, or we have packet switch where we're sharing with other people, the internet is like free for all. You have it's this open internet, this communication that happens there. You've got the cloud. The cloud is made up of lots of different service providers. They have lots of different networks in there. And you have an internet service provider. You connect to that internet service provider, and they connect you to this network here, the web. And then same thing, you would have an internet service provider that would connect each one of these sites. And then through the internet, then you would make a connection between all of your sites through something like a VPN. So that is the internet. So this is a very cheap way of going about doing this. And it can be, so not only is it inexpensive, but you can get really fast speeds. You don't have the same dedication as if you go to the packet switched where you're buying some services, some packet switch services like MPLS. And it's not going to be nearly as expensive as dedicated lines. So this is a good route to go because you get some speed with it. It's relatively cheap, but there's not necessarily a guarantee because the internet can be unstable at times and connections can drop and stuff. So you don't get the same guarantee with things like a dedicated line or an MPLS. Examples of this would be anything that you know of already that you can connect to the internet through an internet service provider. So some examples of this is DSL would be an example, getting it through some sort of cable company, getting it some sort of optical fiber connection, municipal Wi-Fi, cellular data, whether it be 3G, 4G, 5G, LTE, satellite internet would be an example of this, WiMAX, IEEE 802.16. So all of these are examples of ways of just connecting to the internet and providing for that internet service provider. A lot of businesses make the connection nowadays through this. All right, in this video, we talked about those WAN connections and what a WAN connection is, what a WAN is versus what a local area network is. Then we got into some WAN types, what you would be getting from an internet service provider, what you'd be getting from a service provider, whether it's a dedicated link, whether it's a switched network, or whether it's the internet and you're getting access to the internet. So those are the different WAN connections.